All right, so starting with number 1, it just says, in a triangle, a perpendicular bisector is, so you need to know what a perpendicular bisector is. You need to be able to close your eyes and imagine it, right? It's the thing that cuts through a side exactly in half, right? It cuts it exactly in half, and when it cuts it in half at a perpendicular angle. That's all you need to know to answer this question. So in a triangle, a perpendicular bisector is blank to a side. I'm guessing that's probably perpendicular to a side of the triangle and intersects that side at its midpoint. So it's perpendicular to a side, and it intersects the side at its midpoint. All right, next one. In a triangle, an angle bisector divides an angle into two congruent angles. Okay, in a triangle, a median connects a blank with the blank of the opposite side. So this is referring to the side. So this is going to be the midpoint. So it connects the blank with the midpoint of the opposite side, the vertex. In a triangle, an altitude connects a blank with the line containing the opposite side and is blank to that line. So this is going to be right or perpendicular. This is perpendicular to that line, and it connects a vertex. An altitude connects the vertex to the opposite side's line at a 90-degree angle. And again, you need to be able to close your eyes and visualize all these things. Angle bisector, perpendicular bisector, what does that look like? What does an altitude look like? What does a median look like? Right? And form some triangle in your mind and be able to at least imagine it. Okay, so going on. If G is the midpoint of ED. So this is all just big ifs, right? It's not necessarily, but they're saying if it was. So if G is the midpoint of ED. So G is the midpoint of ED. So I guess I'll just mark this and then I'll erase with an eraser. So if G is the midpoint, that means this side, G to E, that's equal with G to D. So if G is the midpoint of ED, then CG is the median of EDB. So CG, is that the median? Median would have to go from the midpoint. Is that the midpoint right there? To the vertex, right, of EBD. Y'all see the bigger triangle? EBD. Is this the vertex? Is that the vertex of the bigger triangle? No. Okay, so it doesn't work. So that's false. If CF, okay, if CF is perpendicular to ED. So if CF is perpendicular to ED. So that means if that's 90 degrees, then CF is an altitude of both ECD. So here's ECD. So it is an altitude. It connects to the vertex of ECD, right? Straight down, hits at a 90-degree angle. And ECG. ECG. So yeah, same thing. Vertex, straight down, 90-degree angle. True. All right. If EB and BD are perpendicular, EB and BD, that's an interesting one, are perpendicular, okay? Then EB is an altitude of, ECB. ECB. Yeah. Oh, ECD. That's true also. That is an interesting one. So let me erase this stuff, get this out of the way. And since we're almost done, we're right here. It's talking about that this line right here, E to B, is an altitude of this triangle. Do y'all see how that would be possible? You need to be able to do this in your mind, but if you take this triangle and turn it like that, right, and that's the base, here's the perpendicular angle from the vertex straight down to the base. Okay? If CG is a median, okay, if CG is a median of ECD, okay, so that means this is equal to that. If it's a median, then G is the midpoint of ED. Yeah, absolutely. G is in between E and D. So that's true. Each leg of the right triangle is also an altitude of the right triangle. That's an interesting one. What do y'all think? Yeah, you have to be able to visualize it, but each leg of this right triangle is also the altitude, is also an altitude on that right triangle. Okay. So going on, if you looked at your answers, it actually gave equations for these lines. That's because it actually said write the equation for the line, right? I just said simply draw. So draw the altitude of a triangle ABC through vertex B. So it needs to go through this vertex. So there's the vertex. I need to draw it straight down. So I'm guessing that would be like right here-ish. Not quite. Probably should have been like more like right there. Needs to be at a 90-degree angle. Next one, draw the median of ABC through vertex A. Okay, here's vertex A. So the median would be connecting it to the opposite side's midpoint, right there. So I'm going to go straight line, try to do the best I can with a straight line. From there to there, which means that this side has to be equal to that side. All right, any questions so far, guys? Again, it's just all vocabulary, 100% vocabulary so far. Okay. And a triangle, the point of concurrency, what does that mean? Yeah. Yep, where they all come together. All right? The place where they all come together. The point where they all come together of the perpendicular bisectors is called what? Circumcenter. The point of concurrency for perpendicular bisectors is equidistant from vertices. Good. Some people are getting this stuff. It's a bunch of vocabulary. Vertices. All right. In a triangle, the point of concurrency of an angle of the angle bisectors is called what? Incenter. Nick is just so bored because he's dominated this. Nick, do you know all the vocabulary words? Yep. Okay. Good. The point of concurrency of the angle bisectors is equidistant from what? Sides. In a triangle, the point of concurrency of all the medians is called what? Centroid. There's no question about this, but what is a centroid? What's special about the centroid? It's 2/3, right? Along the way from the vertice to the side. Okay. In a triangle, the point of concurrency of all the altitudes? Orthocenter. All right. Fill in the blank. Always, sometimes, or never. This takes quite a bit of thought right here. It really does. A median of a triangle, is it always, sometimes, or never, has a midpoint as one of its endpoints? Always. That's something that defines a median. Always. A median of a triangle always, sometimes, or never lies outside of the triangle. It never lies outside the triangle. A perpendicular bisector of a triangle always, never, sometimes contains a vertex of the triangle. Sometimes, right? All it needs to do is make sure it cuts the side in half at a 90-degree angle. But sometimes it passes through. Sometimes it actually passes through the opposite side's vertex. The angle bisectors of a triangle sometimes, never, always intersect at a single point. Always. What's the point called? Incenter. Okay. Circumcenter of a triangle always, sometimes, never lies outside the triangle. Ooh. Sometimes. Good. All right. Getting closer to actually working some problems. The centroid of a triangle blank lies outside the triangle. That is actually never. You can't draw all of your medians and have them intersect outside the triangle. So it never intersects outside the triangle or exists outside the triangle. The orthocenter of a triangle always, sometimes, never lies on the triangle. Sometimes. Sometimes. Sometimes lies on the triangle. So in other words, if you draw 3 altitudes. Sometimes that lies on the triangle. Sometimes it lies inside. Right? Sometimes it lies outside. Okay, the incenter of a triangle sometimes, never, always lies on the triangle.
Sometimes.
Ooh. Never. The incenter, that's all the angle bisectors, right? So let's just imagine this for a second. This will actually be pretty beneficial to imagine. And this is all they're doing. So here's a random triangle. I'm not thinking about it before I draw it. There it is. If I take all of the angle bisectors, right, and connect them, check it out. This angle bisector cuts this angle in half. That one cuts that angle in half. This one cuts this angle in half. Is there any way they can possibly all intersect outside the triangle? It's always going to be pretty central, okay, on the triangle. Okay, so going on. Whew, I'm kind of tired of vocabulary. Should we keep going with it? Okay, let's go to 31. All right, if QV, all right, so V is a centroid, yeah, these are some good questions. So V is the centroid of triangle PRT shown to the right. Okay, so that's the centroid. Remember the centroid is what distance from the vertex to the opposite side? 2/3. So that's a third, that's a third. So 1, 2, 3/3, 1, 2, 3/3, 1, 2, 3/3. Okay, QV is 3. That's 3, okay. Then QT, so all the way across is 3, 6, 9. VS is 7, so that's 7. So PV is just from here to here, so it's 7 times 2, 7, 14. All right. Let's see, what does the next one say? It says, ooh, that one's kind of nasty. See if we can do it real quick. All right, QV. All right, QV is 3m minus 1. How many of you actually answered this? Okay, QV is 3m minus 1. Q to V is 3m minus 1. And then Q to T, the distance all the way across, is 7m plus 3. Okay, and then it says find the value of m. So the distance all the way across this thing is 7m plus 3. Now, quick question. How many times does this go into the entire distance all the way across? 3 times. So the way you would actually set this up is 3 times 3m minus 1. It takes 3 of these distances to equal 1 of the big distances, right? It's the same idea, but it's kind of applied in a different context. And I think you guys can probably solve it from there. Does that make sense? Yeah. How many of you actually got stumped on that question? Oh, okay.
I did it wrong. I put 2 instead of 3.
All right. So that's how you would set it up. Multiply it all out. So for those of you that kind of mess the distribution up, it would be, it'd be 9m minus 3 equals 7m plus 3. You'd have, I'm solving this quick, but 2m equals 6. So m equals 3. All right. So going on, what is this question? It says, use the figure below, triangle ABC is isosceles, and angle A, I guess that's the angle. Angle A is the vertex angle. All right, let me zoom out a little bit so we can pick all this up. AD is the perpendicular bisector of BC. Okay, so AD is the perpendicular bisector of BC. So that's means that if BC equals 2x squared, so if BC equals 2x squared, so the distance from here all the way across, that's 2x squared. And BD, so half that distance is 4x plus 21. So this is 4x plus 21. Find the value of x. So how many of these go into making this whole distance? So it's the same idea. 2 times 4x plus 21 equals 2x squared. Guys, that actually gets into quadratic formulas. Okay? Nick might be able to solve this. If you guys remember from Algebra 1, you probably touched on it a little bit. Like quadratics. Do y'all want to solve it? Quick recap of basic Algebra 1, some of Algebra 2 stuff. All right, so distribute into here. So you have 8x plus 42 equals 2x squared. And you don't have to write all this stuff down, guys. This is Algebra 2. You're going to learn this next year. Okay? Let me even stop recording on this.